Hello friends and welcome a lecture on dimension analysis. Today we are going to see what is meant by dimension analysis, importance of dimensional analysis and methods of dimension analysis. So dimensional analysis is a method of dimensions. It is a mathematical technique used in research work for design and conducting model tests. It deals with the dimensions of the physical quantities involved in the phenomena. So dimension analysis is a technique which reduces the number of variables in the experiment. In turn, it reduces the cost of experimentation, and in turn, it reduces the time of the experimentation, and it is one of the reliable methods. So all physical quantities are measured in comparison with three basic dimensions or fixed dimensions, that is mass, length, and time, which are very much important in the fluid mechanics. In some of the problems of fluid mechanics, if heat is involved, then temperature is also considered one of the basic fundamental dimensions. Now here, before understanding the dimensional analysis and its methods, we have to see the dimensions about the quantities. So as we know, we have learned that there are in fluid mechanics, or there are some fundamental dimensions that are nothing but mass, length, time, if temperature is involved, theta. These are the some fundamental dimensions. And some dimensions, some quantities are there derived from these particular fundamental dimensions by using some laws or by using some empirical relations. Okay. So now here, we have to some that quantities are called as derived quantities or called as secondary quantities. So uh, these derived quantities possesses more than one fundamental dimensions. So that is called a derived. For example, length is only one quantity, length L. Okay, mass M, and if we consider velocity, meter per second. So it involves mass, length also there, and time also there. So in that case, that quantities are called as derived quantities. So simple definition is already given. That is, it is terms quantities which involves more than one fundamental dimensions. So for example, and all these quantities we have to express in their fundamental form, or we call it as a MLT form. M stands for mass, L stands for length, and T stands for time. Now here some of the fundamental dimensions I am giving. So fundamental dimension already we are knowing. So one is what? It is length. Is there one is length, then mass and time. So L dimension is going to be L only. There is M mass. There is M only L raised to 0, T raised to 0. We can add. Then afterwards time is only T. So these are the fundamental quantities. Now secondary quantities, which are the dimension we'll see. Now here geometric parameters are there. Here we can say that geometric parameter one is the area. Its dimension is L square. So it's only L square. Then M raised to 0 L square. Then T raised to 0. That way we have to write. Then volume L cube. Like way kinematic quantities. Kinematic involves the quantities related to velocity, acceleration. So that our example are velocity. The dimension is meter. Unit is meter per second. So its dimensions will become L raised to 1, T raised to minus 1, or L T raised to minus 1. Like way angular velocity, it is nothing but what? Radian here per second is there. Therefore, it is velocity per second. So we can say it as a T raised to minus 1. Acceleration meter per second square, L raised to 1, T raised to minus 2. Like way angular acceleration alpha, it is T raised to minus 2. These are angular velocities, again differentiation with respect to time. In kinematic viscosity is nothing but what? Nu is equal to meter per second square, and is equal to what? Meter per second square. It is equal to, sorry, meter square per second. Sorry, meter square per second, it will become L raised to L square T raised to minus 1. So all these quantities are there, secondary quantities. We have to express in terms of fundamental quantities. Then these are kinematic. Then dynamic quantities are there. Force. Force is equal to Newton, and Newton is equal to what? F is equal to M A. M means kg. S means A means M meter per second square. So Newton is equal to kg meter per second square. So kg meter per second square means kg means m raised to 1, then t raised to kg meter L raised to 1 and T raised to minus 2. Like weight means force again, same dimension. Specific weight is nothing but what? Newton per meter cube. Then it will be M raised to Newton per meter cube. So Newton is equal to, again we have to go for Newton means kg meter per second square divided by meter cube, and that way it will become what? The dimensions of here, it will be M raised to 1, L raised to minus 2, T raised to minus 2. Like way dynamic viscosity, Newton second per meter square. Newton we have to put it as a kg meter per second square, and if you solve that, it will finally it will get that m raised to 1, L raised to minus 1, T raised to minus 1. So afterwards, to solve the methods on the dimension analysis, Buckingham method or Rayleigh method, here we have to know these fundamental dimensions of all the quantities that were frequently using in the fluid mechanics. So sometimes they will ask, write down the fundamental forms or fundamental dimensions of force, weight, shear stress. That 4 quantities they will ask for 2 marks. Like way momentum, etc. So next, now here we have to one example. We are going to solve simple examples are there. Then what are example? Determine the dimensions of the quantities given below. Angular velocity. Angular velocity is nothing but what? Angle covered in radian divided by radian per second. But radian we are considering as a unit only. 1 upon t is equal to t raised to minus 1. Then angular acceleration is nothing but radian per second square 1 upon t here. T square is equal to t raised to minus 2. Discharge is there. Discharge, one is discharge is that area into velocity is equal to area L square into velocity L by t. It will become L cube by t, or meter cube by second, L raised to L cube t raised to minus 1. Then kinematic viscosity, mu upon rho. Mu is equal to mu upon rho, and mu dimensions we know Newton second per meter square. Therefore kinematic viscosity will become what? Here this dynamic viscosity will become shear stress divided by du by dy. Du by dy it will become what? It will be 1 by t, therefore it will become Newton second per meter square. Then it will become what? Is equal to m into, so dynamic viscosity dimensions are coming as m raised to 1, L raised to minus 1, T raised to minus 1. And that's rho, mass upon volume, m upon L cube, m L cube, and therefore kinematic viscosity is equal to that mm will get cancelled. L cube, L minus 1, L minus 3, it will become L raised to 2. When L raised to minus 3 will become 2 numerator, it will become plus, and T raised to minus 1. So kinematic viscosity fundamental dimensions is coming as L raised to square, L square, T raised to minus 1, like wave force, etc. We have to use fundamental relations to calculate these dimensions. So here remember that these quantities, all the quantities that we are going to use in the fluid mechanics, we should know their fundamental dimensions. Then another term is there, it is called as dimensional homogeneity. So when equations are there, we know that there are two sides of equation. One is we call it as a left hand side, and another is what? Right hand side. Then the powers of the fundamental dimensions, that is MLT, if at both sides, LHS side as well as RHS side, if they are equal or identical, then that equation is called as dimension homogeneous equation. Such as one example I am giving here, all the equations that we are using in the science, these are dimensional homogeneous equations. For example, V is equal to square root of 2gh. So if we write the dimensions of example we are going for it, V is equal to root 2gh. Example is what? LHS side is V is equal to meter per second. It will become L raised to 1, T raised to minus 1. In dimensions of RHS side, it will become square root of 2gh. So square root will consider as a square root of 2gh. So dimension 2 is constant, no dimension. G is acceleration, is L upon T square, into H it will become L. So square root of L square divided by T square. But as it is square root, it will become L by T, and it will become L T raised to minus 1. So dimensions of LHS is L T raised to minus 1. Dimensions of RHS is also L into T raised to minus 1. So these two dimensions, that fundamental dimensions power, are equal at both sides or identical. Therefore, this equation is called as dimensional homogeneous equation, and the property is called as dimensional homogeneity. Now, to solve the problems on this particular dimension analysis, we have to use two methods. And these two methods are very, very important. So one method is there, it is called as, there are two methods. One is Rayleigh's method and one is Buckingham's pi theorem. When number of variables are very less than 3, etc., then we have to confidently we can use the Rayleigh's method. And if the fundamental dimensions are more than 3, then this Rayleigh's method will become difficult and we have to use Buckingham's pi theorem method. Now today we'll go for the explanation of what the discussion on Rayleigh's method. So this method is used for determining the expression for a variable which depends on maximum 3 or 4 variables only. Now, if the number of independent variables becomes more than 4, then it's very difficult to find. So I told then we have to go for Buckingham's pi theorem method. Then let us consider that what is this method. X is a variable. So X is a variable which depends on x1, x2, up and x3 variables. Then according to Rayleigh's method, X is a function of, X is a dependent variable, and this X is called as dependent variable, and x1, x2, x3 are called as independent variables. Okay. So let us, X is a function of x1, x2, x3. So mathematically we can write as a x1, x is equal to f of x1, x2, x3. Then according to Rayleigh, it can also be written as x is equal to k, that f we can replace k into x1 raised to a, x2 raised to b, x3 raised to c, where k, a, b, c, that's k is there, a, b, c are the constant, and these are k is constant and a, b, c are also constant, and these are the arbitrary powers of this x1, x2 and x3. And the values of k we can calculate by using the powers or fundamental dimensions. So we know that equations are dimensionally homogeneous. So fundamental dimensions of LHS set is equal to fundamental dimensions of RHS set. Like way, by equating powers of that mass m, powers of L, powers of T, we can calculate this A, B, C by creating some equations. Now we'll go for numerical so that we can understand what is this Rayleigh's method. So here example is there that example is there that here the period of a pendulum depends on L of a length of a pendulum and acceleration due to gravity. Derive an expression for the time period. Now these are going to be the example. Now here the time period of pendulum. So this is a t is a dependent variable. So this t is depend on length of pendulum, and it depends on the acceleration due to gravity. So we can say that, then in that case we can say that t time factor t is a function of L and G. That we can write t is a f of L comma G, and therefore we can say that t is equal to L k into L raised to a, G raised to b, where k is constant and a, b are arbitrary powers. Now we have to see we have to find out this particular dimension a, b, c, and for that what we have to do is there we have to substitute the dimensions of t. T is nothing but what? Time period. So t is nothing but t raised to 1 only, and is equal to k into dimensions of L is meter, that is L, and L raised to a, and acceleration due to gravity means L raised to L into t raised to minus 2 bracket raised to b. Then we have to calculate this a and b. Therefore powers of t or power of t is equal to 1. There is no term is equal to 2 is equal to 1. LHS had only one power is equal to 2 minus 2b. Therefore b is equal to minus 1 half. Similarly powers of L we equate, then 0. This side is going to be 0. 0 is equal to a plus L raised to b, means what? B, a plus b. Therefore, but we know b is equal to 1 by 2. minus 1 by 2. Therefore, A is equal to minus B is equal to minus 1 half, so 1 half plus 1 half. Therefore, we can say that T is equal to K into L raised to K into L raised to 1 by 2, G raised to 1 by 2, minus 1 by 2. Therefore, K is equal to square root of L by G, and we can say that that means L 1 by 2 means square root of L, and G raised to minus 1 by 2 means it is 1 half square root of 1 square root of G 1 by G. Therefore, this will become what? K is equal to square root of L by G, and the value of K by exponent. If you know the value, otherwise you keep the expression as it is. That is T is equal to K into root of L by G, or we say that here it is going to be T is equal to, if we know the expression K value, if you are determining by experiments, then K is equal to 2 pi. Therefore, T is equal to 2 pi square root of L by G. Likewise, we have to write the fundamental relation with this with respect to the dimensions. That is called as dimension analysis method. And similar type of numericals are there, but if the variables are more than 3 to 4, then this method will become complicated, and we have to go for the Buckingham's pi theorem method. Okay, so next lecture we'll see in detail the Buckingham's pi theorem method. Till that, enjoy. Thank you very much.